Welcome to the ArcMMA. In this video, you will learn how to process and analyze data on our Agilent 6230 LC-MS system using MassHunter qualitative analysis. We have several videos available in this series that may be helpful to you. Links to these videos will be available in the description of this video. This video will cover how to process data acquired with both the ESI and DART sources, along with some basic data analysis methods. Once data has been acquired, open the MassHunter qualitative analysis program. Once the program is open, select the folder icon in the top left corner of the toolbar. This will allow you to open the saved data from your sample. You previously specified the location of this data when completing your work list. For the purpose of this video, we will be using data from the caffeine samples that we ran in the sample preparation and data acquisition videos. When you open the folder containing your data, a chromatogram of your data will appear. Data acquired using the ESI source is automatically calibrated against reference ions during data acquisition, so processing this data is very simple. The next step is to extract a mass spectrum from the chromatogram. First, left-click and drag to select the peak of your chromatogram. Then, right-click on the selected area and select Extract Mass Spectrum from the pop-up menu. The mass spectrum will then appear below your chromatogram. This data will also appear in the Data Navigator area under the User Spectra section as a scan of the chosen acquisition time range. You will then need to subtract the background data from your mass spectrum. To do this, left-click and drag to select some of the baseline of the chromatogram. You can do this either before or after the peak. Then, right-click the selected area and select Extract Mass Spectrum to Background from the pop-up menu. A second mass spectrum will appear, and the scan will be added to the Data Navigator under the section Background Spectra. Right-click on the extracted spectra of your analyte peak and select Subtract Background Spectrum from the pop-up menu. This is your final mass spectrum that you acquired from the sample. Processing data that was acquired with the DART source requires a manual calibration. First, extract the mass spectra for both the calibrant peak and your analyte of interest, and the background spectrum. This is done exactly the same way as mentioned previously, except you should have two scans under the User Spectra section now. Select the spectra for both the calibrant and your sample, then right-click and select Subtract Background. To manually calibrate this data, select the spectra that contains the calibrant data. Right-click and select Recalibrate. This should bring up the recalibration menu in the bottom left section of MassHunter. Find the correct reference list file by clicking the three dots and selecting the calibration_dart file in the calibration folder that's in the main MassHunter directory. In the Reference Mass List drop-down menu, locate the DART calibration mass lists. Then select the list that corresponds to the mode in which your sample was run. Our caffeine sample was run in positive mode, so we will select Jeffamine, the positive mode standard. Right-click on the spectra for the calibrant and select Recalibrate again. This should now fill in the checkboxes for the peaks that the software was able to find in your calibration spectrum. Now, select the spectrum of your analyte in the User Spectra list, and then click the button in the Recalibration section that says Calculate Manual Recalibration and Apply to Highlighted Spectra. It is a green plus sign next to a green arrow. Your spectrum is now ready to be analyzed. Now that you have successfully extracted and possibly calibrated your mass spectrum, you must also learn how to manipulate it. In order to move left or right in the spectrum, left-click and drag along the bottom axis. To zoom in on a more specific range of mass to charge, right-click and drag along the bottom axis. The y-axis functions in the same manner. In order to zoom out of the spectrum, right-click and drag left along the bottom axis. You can also utilize the buttons in the top left of the mass spectrum toolbar. The diagonal arrows allow you to auto-fit the entire contents of the spectrum. The horizontal arrows will auto-fit just the x-axis data, and the vertical arrows will auto-fit just the y-axis data. The program auto-selects a color of the mass spectrum. However, if the color is hard to see or you would like a different color, it is easy to change. Simply right-click on the spectrum and select Change Color in the pop-up menu. Now that you know how to move and manipulate the spectrum, you can analyze your data. Let's explore some of the tools provided in MassHunter Qualitative Analysis to analyze your spectrum. The first tool that you can use is the mass calculator. This is located in the toolbar underneath the chromatogram, but can also be found in the Tools menu at the top of the screen. When you open the mass calculator, it will replace the chromatogram on the screen. Here, you can enter the molecular formula of your desired species in the Base Formula section. For example, we will enter C8H10N4O2 for our caffeine sample. If you ran your sample in positive mode, select positive ions, and then select any of the positive adducts that may have occurred in your sample. If you ran your sample in negative mode, select negative ions, and then select any of the negative adducts that may have occurred in your sample. Then, in the area labeled Compare M to Z, enter the mass to charge of the corresponding peak that you believe to be your species. For example, we are going to enter 195.0879. Then, press the play button located in the top left of the mass calculator window. A table displaying the possible mass to charge ratios of the various adducts specified in your search will display. In the table, there's a column labeled Difference ppm. This number will show how close the peak mass to charge that you entered earlier is to the expected mass to charge of the various adducts. If nothing appears in this column, the mass to charge of the peak you're investigating is too different from the expected monoisotopic masses of the formula that you entered earlier, and an accurate mass cannot be confirmed. Once you have used the mass calculator, you can now use the Generate Formulas feature. This is located in the same toolbar as the mass calculator. You can also find it by navigating to the Method menu above, selecting Method Editor, and then finding the Generate Formulas function in the Method Items menu. If you ran your sample in positive mode, select any of the positive ions that may have occurred in your sample. If you ran your sample in negative mode, select any of the negative ions that may have occurred in your sample. Located at the bottom of the Generate Formulas window is a table labeled Elements and Limits. Here is where you enter the components of your species. For example, caffeine has 8 carbons. Thus, in the row for C, we entered the minimum and maximum value as 8. You can enter different numbers for the minimum and maximum value if you want to see any species that have the amount of that element in that range. If there is an element in your species that is not present in the table, you can add it by entering the element into the box beneath the table and pressing the green checkmark. Once all of your elements are entered, left-click and drag to select the peak in your spectrum that you think corresponds to your species. Then, press the green play button that says Generate Formulas from Spectrum Peaks that is located in the top left of the window. The program will produce a list of compounds as well as a score to determine how well they match the peak. This further confirms the identity of the species. If you find species in your data that you are unsure of, you can compare them to our database of common background contaminant ions and adducts. This Excel file can be found on the desktop. For example, polysiloxane-based vacuum grease is a common background contaminant that ionizes readily in electrospray ionization and can easily contaminate the instrument. Other common background contaminants are synthetic catalysts, polyethylene glycol, or PEG, plasticizers found in rubber tubing, and many more common laboratory chemicals and materials. Mass spectrometry is very sensitive to background contaminants, and often these types of chemicals will be observed in lieu of your analyte of interest because they are more efficient at ionizing even if they are in your sample in trace amounts. Once you have finished processing your data, it is now time to export it. You can use the Snipping Tool application to create a screen capture of your mass spectrum, chromatogram, mass calculator, and/or your generate formulas results. If you wish to export your raw data, right-click on your sample spectrum and select Export. Choose the file format that you prefer and then specify a file location. Click OK. Once you have successfully analyzed and acquired all of your data, you can save and close your files from the program. Do this by selecting the file that you wish to close and then selecting the Closed Folder icon at the top of the screen. This will then prompt you to save and close your data and leaves the program ready for the next user. Now you know how to process data on our Agilent 6230 time-of-flight mass spectrometer system using MassHunter qualitative analysis. Please be aware that you are not a fully trained user until you take an in-person proficiency test with an ARC MMA staff member. Thanks for watching, and we'll see you in lab soon.